Okay, welcome back to the remainder part of lesson 3.2. All right, so this one we are going to divide. We've added, we subtracted, we multiplied. Now it's your favorite divide. All right, so there is something that we have to do. It's called a complex conjugate. All right, and guys, this actually goes for example 4. I just was trying to save space on the paper, so if you need that, this one goes for example 5. So pairs of complex numbers of the form a plus bi and a minus bi, where b is not 0, are called complex conjugates. So basically it's the same values, but one with a plus sign in the middle and one with a minus sign in the middle. Consider the product of the complex conjugates below. So we need to know this because in example 5, we need to use the conjugate in order to solve this. All right, and so what we're going to do is we're going to use the conjugate of the denominator because we cannot have a denominator with an imaginary value. Just like we've talked about in the previous lesson where you couldn't have a rational number, a square root in your denominator, you cannot have an imaginary number in the denominator. I don't make the rules up, I just follow them. All right, so I'm going to rewrite this so I have some room. So 4 plus 3i over 2 minus I. So based on that definition that I just read, that means I'm going to use this conjugate because I want to get the I out of the denominator. And the way I'm going to be able to do it is if I multiply by the same thing, but a plus instead of a minus. And then I'm going to do that same thing on the top. Because remember, I can do whatever I want as long as I do it to both parts. All right, and so now we're basically going to do the box method twice. I haven't done a full method, so for those of you that like full method, I can do it with this one, I guess. So we can try it that way just to see if you like it. So if we do 4 times 2, we get 8. And then we do 4 times I, we get 4i. So maybe if you like the FOIL method, maybe drawing the arrows would help make sure that you don't forget a number. It just seems like with this, people will multiply, let me use a different color. They'll multiply 3i times 2, but then forget to do the last one. So if you do choose to do it this way, just make sure you don't miss something. So 3i times 2 gives us positive 6i, and then we have 3i times I. And so that's going to give us 3i squared. That's just for our numerator. It will be okay. It's basically like doing 2 multiplication problems in one. All right, and then we're going to do the same thing here. So we're going to multiply 2 times 2, and we're going to get 4. Then we're going to do 2 times I, and we're going to get positive 2i minus 2i, because this one, sorry I skipped ahead, negative I times 2 gives us negative 2i. Because remember, our goal is to get rid of the i's in the denominator. So we want these to cancel out. All right, then we have negative I times positive I, and that is going to give us I squared. So let's work on simplifying. We know that we can, in the numerator, we can combine positive 4i, we can combine positive 6i together. In the denominator, we can combine these two together, and they basically equal 0. So if you want to draw a slash through them, you can. If you want to show that they equal 0, whatever you need for your notes. All right. So now I'm going to rewrite this with combining. So I still have an 8. I'm going to add my 4i and 6i together. So I get 10i. And then I have this 3i squared. So I'm going to go ahead and write it as 3 times negative 1. Because remember, I squared equals negative 1. I don't know if this will show a different color. Yeah, it kind of does. So I squared equals negative 1. So just in case you need reference, where did that come from? All right, so that's our numerator. Now we're going to simplify our denominator. We have a 4 that canceled out, and now our I squared is going to be negative 1. Okay. Remember, our goal was to not have an I in our denominator, and that actually happens here. So now we need to simplify. We need to know what is 8, and then we have plus, we'll just write it down. I'll just come over here and we'll keep going. So I'm going to put these together. Let's see, 8 plus 10i. 3 times negative 1 gives us negative 3. And then 4 plus negative 1 gives us positive 3. So now we're just going to combine our real parts in the numerator together, and we're almost done. Do you have to show every single one of these steps? You don't have to, but what happens if you don't and you need help? I can't see what your thought process was. So sometimes it helps me see it, what you're doing. So then, how did I get 3? 4 plus negative 1. I feel like I should have got something different. What did I do wrong? Oh, Stacy. Okay, so when I did negative times a positive, I made it positive here. It was supposed to be a negative. If y'all caught that, awesome job. So my apologies. So then this should still be a negative. And then that does not become 3. It actually becomes 5. Sorry guys, but at least I found my mistake. All right, so we're done, but we're not. Okay, because our denominator can be divided into both of these numbers, we're going to make that happen. So remember, you can add fractions together as long as their denominator is the same. So this is kind of the same as saying 5 over 5 plus 10i over 5. So we can rewrite it this way and simplify. Well, what's 5 over 5? That equals 1. What's 10i over 5? 2i. And that is our final answer. Okay, we're going to try another one of these together. They didn't give us another example for the notes, but we're going to do one of the self-assessment questions together just to practice this again. So I'm just going to do this one. All right, so remember, we want to get rid of this in our denominator. So if you're ready to go ahead and try, you're welcome to pause it and now try all 3. But I will do number 14 before letting you guys try them. All right, so we're going to multiply both by 1 plus I, 1 plus I. Sorry, I didn't get that quick enough. All right, and so now we're just going to multiply. So we have 2 times 1 and 2 times I. So 2 times 1 gives me 2. 2. Okay, moving on. So 2 times 1 gave us 2. 2 times I gives us 2i. All right, and so now we're going to do the same thing to the bottom, but we have to do it twice. So we got 1 times 1. So 1 times 1 gives us 1. Then we have 1 times positive I. So we have positive I. Now we're going to do the same to here. So we got negative I times 1. So that gives us negative I. Remember, these should be opposite. And then we have negative I times positive I. And unlike my mistake last time, I did not make it this time. We have negative I squared. So now we're going to simplify. All right, I can't really simplify anything with the top, so I'm just going to leave it as 2 plus 2i for now. The denominator, I can combine my 2 i's, and those cancel each other out. And so then I am left with 1 minus I squared, which is negative 1. So then I can simplify this. So I'm just going to move it down here. So I have 2 plus 2i over 1 plus 1. That equals 2. So again, I have not changed my numerator because I haven't needed to simplify. All I've been doing is simplifying this denominator. All right, and now again, this one can be rewritten as 2 over 2 and 2i over 2. We can divide 2 into both of those, and so you would get your final answer as 1 plus I. So that would be your final simplified answer. Okay, so now if you would please pause the video and give those two a try. just because the placement was going to not work out. So here's number 15. So we did the FOIL method on both. If you want to do box method, you can, but to save space, I just did the FOIL method. And then I highlighted, whenever I combine something, I highlighted it to the bottom one. These both are divisible by 5, so we end up with 1 plus 3i. All right, so please pause your video and work on, or give number 16 a try. If you forgot to write 16 down, there's 16. That way you can give it a try. Okay, so here is number 16. Hopefully you got to this part. Since this one didn't work out evenly, I just wanted to show you that it is still similar. So you can separate it as 2/10 minus 14i over 10 because these are both even numbers. So we can simplify 2/10 to be 1/5, and we can simplify this by 2's as well. And so we would get 7i over 5. So even though we still have the denominator of 5, we can put that back together and say 1 minus 7i divided by 5. If you can just think about dividing both of all those by 2 in your head and go straight to this step, that is perfectly fine. So this would be your final simplified answer. So hopefully you didn't find dividing too bad. Now we're going to move on to solving quadratic equations. So we did this in lesson 1. So chapter 3, lesson 1, my apologies. The only difference is they were all positive, so we were able to find plus or minus the value, and none of them were negative. All right, so we're going to do the same thing with these, except for now we're going to have imaginary numbers as our answer. All right, so I'm going to start off with A. We have x squared plus 4 equals 0. And so we're solving for x. We're trying to get x by itself. So remember, just like we did in lesson 1, we're going to subtract the 4 on both sides. So this gives us x squared equals negative 4. So at this part, this is where we then need to take the square root, because we don't want x squared, we need just x. So how do we get rid of that square? We get rid of it by finding the square root. So this becomes x equals, remember you have to do plus or minus because we don't know if x was positive or negative. And then we have the square root of negative 4. Well, in this situation, I can find the value of the square root of negative 4. It is 2i. So I can say x is equal to plus or minus 2i. So the solution would be 2i or negative 2i. And that would be your answer for that one. So it could be either positive 2i or negative 2i. All right, I'm going to do B right here. This one is not much different. So we're going to start off, we need to get rid of this minus 11. So how do we get rid of it? We add it. So then we have negative 47. We're going to add 11. That gives us negative 36. All right, so this part shouldn't be different because you did this in lesson 1. All right, the only difference, like I said, is now we have negative numbers involved. So now we're dividing both sides by 2 so we can get rid of the coefficient. And now we have x squared equals negative 18. So now I don't want x squared, I want just x, so I'm going to take the square root of both sides. And so when I do that, I get x equals plus or minus the square root of negative 18. So negative 18 is not a perfect, or 18 is not a perfect square. So we're going to have to break it up. So I'm going to do it over here on this side. So the square root of negative 18, or we can break this up as square root of negative 1. And I need a perfect square that's a factor of 18. So that makes me think of 9 and 2. So then I would say times the square root of 9 times the square root of 2. And so now I'm just going to simplify. I know this becomes I, this becomes 3, this becomes the same. And then we combine 3 times I gives us 3i square root of 2. So that is what my answer becomes down here. X equals plus or minus 3i square root of 2. I just didn't want you to be like, Ms. Gill, how you got that number? All right, because I know some of y'all would be like, Ms. Gill, you crazy. I don't know what you did. All right, so I'm going to give you 2 self-assessment questions, and I want you to pause the video and give them a try. All right, so if you will pause the video and give these 2 a try. All right, so hopefully you tried this first one. I did show how I went from the square root of negative 28 to get to here. I broke it up here. Remember, this equals I. Square root of 4 is 2, so that's where the 2i came from. All right, so now please pause if you haven't already and try number 8. All right, so number 18, again, I broke up the square root of negative 8, so you could see how I got that final answer. All right, we have 1 type left, and this one isn't going to be too bad because, again, it's something similar to what we did before. All right, and I just want to show it to you. I don't even have any self-assessment questions to go with it. Okay, so we have an equation again, but we have a graph. So remember I told you that the zeros are the same as your x-intercepts. So finding the zeros, we call them roots. We also call them x-intercepts. So if you hear any one of those 3 words, know that they all mean the x-intercepts. Why do we use different values? Because when we're solving this, essentially we're setting it equal to 0, and that's why they call finding the zeros. Sometimes, you know, those mathematicians, they just like to be confusing. All right, so we're going to solve this just like we did the ones in example 6. So if you want to pause now and go ahead and give that another try to have another practice without me, you can, and then come back and see how you did. So I'm going to subtract 20 on both sides. So right now, I want to pause for a second. We're looking at this. Do you see the x-intercepts? Do you see where this blue graph crosses the x-axis? Does it cross the x-axis? I want you to keep that in mind while we solve this problem. All right, so now we're left with 4x squared equals 0 minus 20, which is negative 20. We're going to divide both sides by 4. We get x squared equals negative 5. And then we're going to take the square root, and we're going to say x equals plus or minus the square root of negative 5. Now, I can't break 5 up. It's a prime number, so I can't work this out. This is simplified, except for I can bring out the I. So I can rewrite this as plus or minus negative 1 times the square root of 5. So it becomes x equals plus or minus. Remember, I has to go in front. If you put the I in the back, it looks like it's under the radical and it's going to get marked wrong. So our answer is this. Our answer is where our roots are positive I square root of 5 and negative I square root of 5. Well, these are imaginary, so that means we don't see them. They're not real numbers, right? Just like your imaginary friends, you didn't see them. So even though we still have an equation, this helps us solve it by using imaginary numbers. So if you get an imaginary number as your answer, that means simply that your graph does not cross the x-axis. So it could be facing up above the x-axis. It could be facing down below the x-axis. But if you ever get the x-intercepts, the zeros, the roots, where they are imaginary, that just simply means your graph just doesn't intersect the x-axis, but the graph still exists. So that's why we have to use those imaginary numbers to help. So hopefully that helps you with understanding why we use these. All right, so guys, this was a heavy lesson. So if you have questions, please ask when you come to class. Please star whatever parts that were the most challenging to you so that we can look at some together. All right, until next class.